Peter and Neve go to a large school. One morning they arrive early. While they are waiting, they decide to guess whether each of the next three students to come in the door will be a boy or a girl. Now, I'm assuming here that this door only allows one pupil at a time through it, so we don't have any confusion or vagueness as to what constitutes a student passing through this door. Only one student at a time passes through it. Write out the sample space showing all the possible outcomes. For example, BGG is one outcome, representing boy, girl, girl. So let's write that one down. Now it doesn't matter who the boy is or who the girls are. All that matters is the gender. So this is one outcome. This outcome actually consists of one boy and two girls. And we can write these outcomes out systematically by, first of all, say, considering outcomes that consist of one boy and two girls. Well, here's another outcome that consists of one boy and two girls, and it's fairly straightforward to see that there are exactly three outcomes involving one boy and two girls. Then we could take another case. The second case might consist of two boys and one girl. So this is one such outcome. And we could write out all the outcomes that consist of two boys and one girl. Here's another one. And here's the last one. Actually, we have a symmetry here between these. If we just replace the B's with the G's over here and replace G with B, you'll see that we'll have exactly three outcomes consisting of two boys and one girl. The same number of outcomes as we have consisting of one boy and two girls. Now, so this is two boys. What about three boys? Well, there's only one outcome there. It doesn't matter who those boys actually are. They could be the same boys but in a different order. You could have B1, B2, B3. These are specific individuals, and we could imagine rearranging them, but that doesn't matter. We're only interested in the gender. So there's only one way that three boys can pass through this door. And the other option, of course, is three girls. And if you think about it, that's all there is. Peter says these outcomes are equally likely. Neve says they are not. What do you need to know about the students in the school to decide which of them is correct? Well, if all these 8 outcomes are to be equally likely, then we would expect that the probability of a boy passing through that door is the same as the probability of a girl passing through the door. These have to be equal. You know, if the probability of, say, a girl passing through the door is very, very small, then the probability of 3 girls would be extremely small. It would be much smaller than the probability of 3 boys. You know, if the probability of a girl passing through the door is very small, it means that there are very few girls in the school compared to boys. Now, for the probability of a boy passing through the door to equal the probability of a girl passing through the door, we have to have the same number of boys as girls in the school. So, these probabilities must equal a half. The two probabilities have to add up to 1, of course. The probability of a boy passing through the door or a girl passing through the door must equal 1. There are only 2 options. There are only 2 genders to consider. If all the outcomes are equally likely, what is the probability that the 3 students will be 2 girls followed by a boy? So 2 girls followed by a boy can be written as GGB. Well, we're saying that the probability of a girl passing through the door is equal to the probability of a boy passing through the door, assuming that, you know, we have a perfectly random system. We have equal numbers of boys and girls, and you know, we don't have an imbalance in the probabilities of a boy or a girl entering the door. The chances are the same for this particular time that you know, these students are counting, Peter and Neve. So what is the probability that the 3 students will be 2 girls followed by a boy? Well, these are 3 independent events, so the probability of this happening is the probability of a girl multiplied by the probability of a girl passing through the door times the probability of a boy passing through the door. That's a half times a half times a half, because these are independent events, which is 1/8. Of course, we can also get it just by considering the sample space. We have 8 outcomes, 1, 2, 3, 4, 5, 6, 7, 8. And one of those outcomes is GGB, this one here. So that's 1 out of 8. We could have worked it out that way by counting the number of these outcomes that we need, desirable outcomes. Well, there's only one of them, 2 girls followed by a boy, and putting that over the total number of outcomes, which is 8. Neve guesses that there will be at least one girl amongst the next 3 students. Peter guesses that the next 3 students will be either 3 boys or 2 boys and a girl. Who is more likely to be correct, assuming all outcomes are equally likely? Okay, let's look at all 8 equally likely outcomes, and let's highlight those outcomes that consist of 3 boys or 2 boys and a girl. So that's Peter's guess. So I'll highlight this in blue. So here they are, 3 boys or 2 boys and a girl. So this option consists of 2 boys and a girl, so does this one and this one. Now let's look at Neve's options. Neve says that these 3 students will consist of at least one girl Okay, so let's highlight all the options that consist of at least one girl. These are Neve's options. I'll write N next to it. This one consists of at least one girl as well. So does this. At least one girl means one or more girls. Now we can write down the probability that Neve's guess is correct. I'll write that as P of N, where N means Neve's guess. Well, we count the number of outcomes, favourable outcomes for Neve. It's 1, 2, 3, 4, 5, 6, 7, and we put that over the total number of outcomes, which is 8. Then we can look at Peter's guesses. Probability of Peter's guesses. So we count the number of favourable outcomes for Peter, which is 4, put that over 8. Straight away we can see that Pn is greater than P of P, so Neve is more likely to be correct.